Hello and welcome to part 3, GraphQL Backend Toolbox. I really wanted to also use this as an opportunity to rant a little bit about separation of concerns, at least on the backend, and common use cases that I've run into for manipulating data on both the schema level and the backend level. And so before I really dive into what goes into what, actually no, I'll just go ahead and do that and I'll talk about it later. So data logic, that's who gets what data. So user access management, permissions, things along those lines. Data interactions, and what I mean by that is, let's say you have a marketplace application and someone buys a particular product and you want an increment someplace else, and that's a different field. You do that incrementation whenever it's purchased, that's a data interaction. Or let's say you delete something and it cascades and deletes a bunch of other things, that's a data interaction. That's handled by foreign keys in Django, by the way, and I didn't mention it in the last portion specifically because I wanted to talk about it here. And really it's anything that's involving the CRUD operations, create, read, update, delete. I argue that all of that should be in models.py. And the reason for that is, and this is something I run into other applications, and I even ran it into it with the application I was building with, at least early, with this particular frame set, and I realized, oh, I don't have to do that anymore. And this is a big strength of this infrastructure, is that oftentimes when you're building web applications, what happens is your backend, excuse me, fighting off a cold here, is your back end ends up reflecting the front end data structure, which isn't necessarily the best for having a good database schema or restoring the data or maintaining the data. And I've run into that over and over again, or doing reporting or something along those lines. With this structure, what you can do is you can just let your data be data. You can go ahead and construct a nice database schema and then store things as you want, create things as you want, read, update, delete, all the CRUD stuff. And then if you need to make it look a different way based on what you already have, you can go ahead and do those manipulations at the endpoint logic. So when you're spitting it out, you just have an isolated space where you can do all of that data munging to make it more palatable for front end. And I think I actually use that exact language later. You can basically make it easier to use for the front end UI rather than construct. So essentially, rather than constructing your entire database and the database model for your front end and making it easy to work with on your front end, you can do all that logic at the GraphQL endpoint schema construction point, and then just let your backend data model be a nice, easy to maintain data model in and of itself. And yeah, I think that's one of the biggest strengths of this architecture. So endpoint logic, before I get too far off, that's what I would say. It's just all the data munging. So if you have zip codes, for example, and you want them to look a little bit different, let's say you're in a medical application, you're only allowed to display so much information, you can do all of that here. And actually, that's not something you should be doing, so ignore that. But anyway, point being, whenever you want to do something to make it more palatable for the front end, you want to make it look a little bit different, you want to construct a JSON object, something along those lines, I would argue put it here, and that's in schema.py. So before I get too much further, I know people are going to wonder, well, what about login, logout, and permissions? That should all be handled in the backend, in the models section, and that's on the django-graphene portion. There is a wonderful library called django-graphql JWT, and that is the website right there as far as that front header, that allows you to create tokens. You can send them to the front end, and essentially you create these endpoints that allow both log in and log out. And the advantage of that is not only does it create a JWT token, it also automatically logs in that user in the Django backend with whatever permissions and etc. that they have. And so you can basically create a login, logout around JWT pretty easily. It gives you a series of decorators to do that. And essentially you can protect your models with those decorators. So if you have a particular piece of data that you want protected only at login, you can have the @login required decorator around that model. And unless the users log it in, they're not going to be able to see it. Or you can do use these other functions, or I should say these other decorators, which they're function. Anyway, you can use the decorators for however you want to set up your permission system, which makes it a lot easier to work with. That's kind of the last portion I'm working with my application, actually, mostly because of the because of other issues. But this actually has been, I've tested this, it works really, really well, and it's pretty easy to use and get set up pretty rapidly. Anyway, backend ORM tools. So there's the foreign key, which is basically just your model relations within the Django ORM, and it provides really 3 different sets of things you can do. So essentially whenever you create a foreign key, you automatically have to define what happens when that foreign key is deleted. And you can say, okay, cascade, which means we're getting rid of everything related, set null, which means you're setting that, that field in the current data model to 0, or you just do nothing, which means you still leave that reference, but that reference is no longer existent. There's also a @receiver thing, and what that allows you to do is little bits of logic on pre-delete or post-delete. So let's say you wanted to really quickly, I ran into this when creating the concept of storage objects. So let's say I have a box and a box, but I want to move, but I'm deleting this one box, and this box is in a room. So I want to say the inner box is now in the room, not the outer box. So what you can do is you can use this @receiver message and say, okay, pre-delete, I'm going to take this inner box, and rather than getting rid of it, I'm going to set it to being in the room. And hopefully you guys, I went through that too quickly, but hopefully you guys followed that logic. So essentially, it allows you to do things pre-delete, post-delete, logic-wise. Be careful when you're doing that, because you're going to need to adjust your logic for the onDelete function accordingly. If you're doing a post-delete thing, you might want to have the do nothing method. If you have the pre-delete method, you might want to have a set null or do nothing, so that it can, because essentially onDelete gets fired after the receiver. So I ran into a bit of a bug issue where I had all the code correct, but because I had set onDelete to, I think, cascade, none of it was working. Anyway, there's also overriding save functions, which pretty much handles any of the, I mentioned that use case where something is triggered and then it increments a count. That's pretty much where you want to use that. So going back a second, I'll show you an example of that. So let's say you have a T model here. You've got a cup, and the cup model is set to on. So you got a cup, the cup has T, and you got the T contents, which is a certain amount of liquid, and we're using decimal place field to keep it small in the database. So we can use onDelete. So whenever the cup is deleted, that means this T is going away as well, and we don't care about it anymore. You might want to do something different, and you might want to say, actually, no, I want to move that T to a different object before I throw away that cup. And in that instance, you'd use this pre-delete signal. So hopefully this is more clear than the previous example I blathered out there. So I've defined an empty contents receiver signal. So whenever that's deleted, what I'm going to do is, first of all, you'll notice I set the upper model onDelete function to do nothing, so nothing happens, and I'm just going to update it. In this instance, I'm updating it to null, but maybe I would update it to another cup or a tub, who knows. So here's some examples of onSave, and this is pretty much using that exact same, and this is actually, I think, a fantastic function in Django ORM, because what you can do is you can still use the same save function that's being utilized otherwise, but you can do all this extra stuff in between that you might want to do. So in this instance, I've got my T model, and I'm saying, okay, if the type is green, just update the green count. So let me know how many people are buying green tea, for example, and then save it per normal. And there's a whole bunch of things you can do with this save function. You can see what I mean by data triggering and all of that being happening on the back end. So now let's talk about graphene, which is the schema logic. So, and I know that's like a hard line brain shift, but now we're talking about data munging. This is without Django involved whatsoever. So up top, you can see the dummy data, the object type, and all that's doing is that's just defining the data shape, what's going to be spit out to the front end. So in this instance, I'm literally just creating dummy data. You can see below, I've got my data field that's going to be coming out, which is graphene field, and then I'm going to resolve data. And I'm just literally plugging in a value that's a string, and that will go out. And this is actually, I believe, I haven't tested it, but I believe this is actually a use case that works. So if you want to create just dummy data that goes out for testing for a front-end UI, you can literally construct things exactly this way and just hard code values so that your front-end team knows what they're going to need to deal with if you have a separate front-end team and you're not having to do it all yourself. And graphene's fantastic for this way. Also, let me go back a second. Don't fall into the trap where you're exporting a JSON. I feel like it's much easier to just create a object type where, like class dummy data, that because it's coming out as something JSON-ish to begin with. So it's much easier to just construct a custom object type and then just feed in data from there rather than creating a JSON type, unless you absolutely for some reason need a JSON data type. So here's an example of what I mean by that. So here I've created some example data. I'm going to have a name, an amount, and I'm going to ask whether it's local or not, and that's going to be true or false. And I'm also throwing in a little bit of bonus here. I'm going to say that what's actually stored in the database is a zip code, to talk about data munging a little bit further. So the zip code doesn't know whether it's local or not. It's just the zip code, and that's the piece of data I want stored. I don't want to go any further than that. I don't want to have an extra field, for example, that says whether it's local or not, and whether it's local or not might change to based on location and things like that. So actually I should have probably tossed in a second field for location. Let's say there's just one location for now, but anyway. So now you have your class query with that object constructed. We're letting, I should have actually said T example, graphene field example data right there. So pretend I did, so I don't have to edit this and go record this again. So a little bit of an error here where it says field. There should be example data as the field type being ingested. But now I've created another object called isLocal, and that's just tossing in a field that's, so let's say I've got a T object. I'm just checking the zip code to see whether it's local or not. And then to resolve it, just dumping that data in. Example data, name is, and again, some hard-coded pieces and actual pieces otherwise. Usually what I would be doing in this instance, if I was pulling from the back end, is I would actually pull a specific instance that was being called and then kind of throw in the data from there. But you can see where, rather than throwing back just a general JSON that you're constructing on the spot, it's a lot easier just to create a specified graphene object that matches what you're looking for. And again, all of your data munging and construction can happen here rather than having to manipulate your backend data model. You just have to know what you want on the front end. So as long as you know what you want on the front end, you can, and you have the data to actually fill those user requirements, you don't have to do any extra data manipulation in your models themselves so that it's kind of corrupting your database to fit whatever the front end user needs. And that way you can also, it makes it a little bit easier to deal with multiple users trying to do different things with the same data. So reporting data oftentimes ends up being different than front end data, and here you can serve both purposes effectively depending on who's asking for it. So anyway, review really quick. Graphene object construction allows you to data munge for palatable front-end UI ingestion. Again, so when you create that, within that schema, you can build stuff that's easy to use on your front end. And then Django ORM has a bunch of tools to just make data construction really easy. So if you're on small or medium-sized applications, or if you just want a toy project up, you can really quickly get your data model up, or even like not a complete data model up. There's some Django migration tools that make maintaining your database, I think, a little bit easier. You can just build that all very rapidly in Django ORM. And again, Django ORM, just so you know, it can ingest SQL calls. If you're going to do that, maybe ask yourself whether you really want to be working with an ORM altogether. And I'm going to say this for emphasis, do what works for you. If you want to skip Django ORM altogether and just have SQL calls going directly into Graphene, you can do that. I'm not sure I would recommend that because of a lot of the extra work around validation, things like that, but that's a possibility. That's the nice flexibility of this system. So, and again, if you want to mix, if you want your back-end model to reflect your front-end model because you're not going to have to deal with separate use cases, do that. But anyway, I found that just do what works for you. This is a nice, that's the other strength of the system, is it's simple, it's flexible. And it, if you want to be a little bit more strict and have those data concerns separated to kind of maintain things a little bit down the line, it's helpful for that if you're running into that problem. But if you don't need to. You can just really quickly build your application. I feel like I've said that a couple times over and over again, ranted about it, don't need to go any further. Anyway, I hope you guys run off and enjoy using this. I'm trying to think what I'm even going to cover next. I think I'm actually going to move on to the front end portion of this next and talk about how Apollo ingests things on the other side of things with the next video. So thanks for listening. Hope you guys enjoy this framework.